Good morning, St. Louis University High School. I'm Senior Curtis Riganti, and here's a look at our tropical weather segment for this week. First, I want to talk about, though, storm spotting classes that are coming up during the next couple of weeks. So let's have a look at these. One way to be a man for others, you can help save people's lives with this. This is very important. Skywarn and the National Weather Service rely on storm spotters for their most important information relaying storm warnings, not radar and not other technological stuff. The most important parts are the spotters on the ground. So there are two classes coming up in the next couple of weeks, both on Saturdays, a Level 1 class from 9 to 12 a.m., and then anyone here who is Level 1 already, you can take a Level 2 class from 1 to 4. So this Saturday, September 13th, and next Saturday, September 20th. For the first one, which is in Afton, you do not need to register. For the second one, which is in Florissant Valley, you need to call the number 314-513-4444, and both classes are free. So I hope to see a lot of you out there this weekend. So what is the difference between an extratropical low-pressure system and a tropical low-pressure system? Well, first off, extratropical low-pressure areas, or extratropical storms, form more over in this area of the United States and up into North America and around the world at middle latitudes, not near the equator or the poles mostly. And these are the storms that give us our everyday rain, a little bit of wind, snowstorms, tornadoes, and thunderstorms. So these are just run-of-the-mill low-pressure areas that you'll see Cindy Pressler talking about on the news. Meanwhile, though, a tropical cyclone is much different. These form based off of the ocean, the heat content in the ocean from tropical waves, which are small areas of low pressure moving off of the African coast out here by the Cape Verde Islands. Now, while an extratropical storm derives its energy from mostly upper-level winds and from the difference in temperatures between two different air masses, a tropical cyclone will derive its energy from the heat in the ocean. As the water evaporates into the storm, it will condense and release the latent heat in the water, therefore adding to the energy of the storm. So examples of tropical cyclones are hurricanes, tropical storms. In the Pacific, they are called typhoons. So first, I'll talk about Hurricane Gustav. It formed in the Central Caribbean back in the middle of August, and as it was moving up towards Haiti, it strengthened to a hurricane, and then as it got away from land and away from Jamaica, it hit an area of very high ocean water heat content and was able to strengthen to a Category 4 hurricane with 150-mile-an-hour winds before it ran into Cuba. Now, as it ran into Cuba, the high terrain and mountains disrupted the storm's circulation of wind spiraling into the center. Therefore, as it started to rapidly move into the Gulf of Mexico, into an area where Katrina was able to rapidly strengthen into a Category 5 hurricane, Gustav, affected by its forward speed, its lack of organization from going over Cuba, and upper-level shearing winds, which are winds that are stronger in the upper part of the atmosphere, around 30,000 feet, than the lower part, which blew off the tops of the thunderstorms, therefore spreading out the heat content of the storm and causing it to weaken. So here's a satellite image of the storm before it went over Cuba, and as this is the point where it's a Category 4 hurricane with 150-mile-an-hour winds. This is a visible satellite looking at the very, very strong eye of Gustav. A day later, though, you can tell a major difference. This here is the eye, or what's left of it, of Gustav, as it's weakened back to a Category 3 storm. The mountains here disrupted the flow into the storm, and so the thunderstorms weakened, and it basically looked like this all the way until it went up into central Louisiana. So although it was forecast to be a major storm, it really wasn't that big of one. So we are thankful for that, definitely. Now on to another storm this year, Ike, which is currently, we think, as this is being taped, it should be right around this area here, moving into the Gulf of Mexico and towards the Texas coast. It will likely be a Category 2, 3, possibly 4 hurricane as it goes into the Texas coast. Meanwhile, though, we have this little area of clouds here with a tiny area of showers. This is what's left of Tropical Storm Josephine. This is an example of how upper-level winds in the atmosphere are able to blow off the thunderstorm tops. Some of the winds that will influence this are outflow from a storm like Ike here, or, on the other hand, the jet stream, which early and late in the hurricane season will often cause these type of winds. So Josephine has been declared a remnant storm, so it no longer exists. We'll have to watch it for re-strengthening, but at the moment, Josephine's looks not to be a problem. But that is just a little bit on tropical meteorology. Reporting for KUHI, I am Curtis Riganti.